Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter 15 of our diesel engine class. This is the last chapter of the marine diesel engines course. I hope you enjoy this course. This is the last chapter. In this chapter we are going to be concentrated in the turbochargers, the superchargers, and the troubleshoot, the general troubleshoot of diesel engines. And in the last episode we are going to calculate, we are going to size the turbocharger completely. We are going to do the calculations, the mathematical calculations, in order to know what is the size of the turbo recommended for my engine. We are going to solve it, a real example of an diesel engine naturally aspirated. We are going to calculate the turbo appropriated for that engine, and we are going to select in internet the turbo recommended for that engine. This is the last exercise of this class. Okay, in order to do that procedure, we need to understand some basic concepts related with the turbochargers and superchargers. What is the meaning of a turbocharger? A turbocharger is a fresh air compressor driven by a belt connected to the crankshaft. Not necessarily a belt, probably with a gear contact. Is very common, or with chain, or with pulleys and belt. In gasoline engines is very common, connected by belt. In diesel engines is common, connected gear, with the gear of the crankshaft. Alright, and what is the meaning of the turbocharger? A turbocharger is a fresh air compressor driven by the force of exhaust gases. Yeah? Both of them, I explained before, in my opinion, are highly efficient. There are manufacturers that prefer the superchargers because the superchargers have the ability to introduce extra pressure, boost pressure on the system, and not increment the temperature in the engine room. The turbochargers elevate the temperature of the engine room because the turbocharger uses the hot exhaust gases to move the turbine and produce the suction in the other side of the turbo. But both of them are equally efficient. Both of them can be used. Both of them can be adapted. I'm going to explain later. You can install a couple of turbos in series or a couple of turbos in parallel. Remember, like the connection of the batteries in series and parallel? Similar, exactly the same procedure. And we are going to do the same procedure in our course of hydraulic systems. We are going to connect pumps, freshwater pumps, in parallel or in series, depending what I need. I need more head, I connect in series. I need more flow of fluid, I connect the pumps in parallel. Exactly the same with the turbos. I need more flow of air in parallel. I need more head, more boost pressure, I connect in series. Alright? I hope you enjoy these videos. Alright, the first element in the definition, absolute pressure. Absolute pressure is the total pressure in the combustion chamber. What is the meaning of that? In the combustion chamber, if the engine is naturally aspirated, I only have the atmospheric pressure and the suction pressure. If the engine is turbo or supercharged, I have the atmospheric pressure plus the extra pressure. What is the name of that extra pressure? The name of that extra pressure is boost pressure. This is the extra pressure. What is the atmospheric pressure at sea level? The atmospheric pressure at sea level is 14.7 psi. This is 1 atmosphere. This is at sea level. Remember, what happens when you move it at higher elevations? The pressure goes down. For that reason, the majority of the people say, at sea level you don't need the turbocharger. Yes, but no problem if you have an extra pressure. more power. All right, what is the meaning of boost pressure? Is the additional pressure that we are going to add it in the combustion chamber, additional to the atmospheric pressure. How much is the boost pressure recommended for that engine? We are going to study. In gasoline engines is a little less, the boost pressure recommended for gasoline engines. In diesel engine, the boost pressure could be higher. And I am going to give some personal recommendations in relation with the extra boost pressure, extra additional pressure. Remember that when the engine is supercharged or turbocharged, you can increase the efficiency close to 100% or a little higher. You can convert the engine in an ideal engine with 100% of efficiency. Wonderful. All right, my friends, we are going to use the blow-off valve. I prefer explain later this valve because this is a valve used to regulate the pressure in the combustion chamber, especially when the engine is in idle. Yeah, because when the engine is in idle, you don't need the extra pressure from the turbo. In that case, you need that the turbo spin slower. Yeah, you need send the gases a little out in order to avoid that the turbo introduce extra pressure. In idle, I don't need. Probably at higher RPMs, after the RPMs where the engine is producing the peak torque, probably you need the turbo. In that moment, the turbo send the extra pressure, the boost pressure, and the engine increase the performance. In idle, no. In idle, you don't need. For that reason, we are going to explain later what is the meaning of the blow-off valve. Is basically the west gate in order to send the gases directly outside and avoid that the turbo produce extra pressure. Yeah, we are going to study later. The other name for that valve is the bypass valve. The bypass valve is basically the same. It's basically the same like the blow-off valve, and is used to regulate the pressure, especially when the engine is running in idle. And this is a good picture about the turbo. We are going to start with the turbo, and we are going to check the parts of the turbo, how the turbo is composed, and what is the function of each part, and how those parts work in that system, in that wonderful design, that wonderful system. Let me explain this picture. This picture is, in my opinion, a great diagram of a turbo. We have located here the filter. You remember the filter? All right, this is the filter, and the fresh air enter over there. The fresh air enter over there and enter in the intake manifold. Enter in the intake manifold at high pressure. What is the pressure here? Is the boost pressure. The boost pressure, the extra pressure. Yeah. The air enters through the filter and is compressed in this area. For that reason, the name of this turbine is the compressor wheel. The compressor wheel, because we are going to compress the fresh air over there, and we are going to enter in the intake manifold, and we are going to enter that additional fresh air full compressed into the combustion chamber at high pressure, superior to the atmospheric pressure. How much? We are going to calculate that. Okay, that extra pressure finally entered in the combustion chamber. And what happened outside of the combustion chamber? Okay, in the exhaust gases, in the exhaust manifold, we have exhaust gases. Those exhaust gases enter in the hot side of the turbo. You remember the hot side of the turbo? Exactly. In the hot side of the turbo, enter and move the turbine of the hot side. The turbine of the hot side is the turbine that normally the color is brown. This is the turbine of the hot side, because the turbine of the compressor, the turbine of the cold side, normally is like an aluminum color, like a silver color. Alright, move the turbine. Some gases go directly outside, and other one spin the turbine. Yeah, This is the movement of the turbo. The turbo start to produce energy with the exhaust gases. The input of the turbo is the exhaust gases. The exhaust gases move the turbine, and because the shaft is connected together, this shaft is connected together. In the other side, the air enter at high pressure. The air enter into the combustion chamber, In that moment, in the moment that the air enter in the combustion chamber, at the end of the compression stroke, at the beginning of the intake, both valves are open at the same time, they overlap, and the scavenging is produced. The fresh gases, the fresh air, push the smoke out. Immediately the valves close, and the combustion chamber is filled with pure air, clean air. And right now, the compression of clean air is better. All right, this is the cycle of production of the turbo. Is clear, my friends? You like it? Yes. The turbo should be calculated, because if you added too much pressure, my friends, you can destroy the head. You can remove the head. In race cars, there are a lot of examples you can check in YouTube, a lot of videos where for extra pressure on the head, too much boost pressure, the head of the engine is broken and the head goes out and destroys the cars. Yeah, in drag cars, it's very, very common. Yeah, be careful with the extra pressure. For that reason, you need to calculate how much is the extra pressure that I can add it in that engine. Oh, the engine is new one? No, it's not new. It's 60,000 miles. All right, it's not a new engine. Okay, you need verify the first step. I'm going to explain later the procedure. Is verify the actual compression, the compression of the engine. The compression is good? No, it's not good. All right, you need to replace the rings, the piston rings. You need fix the compressor. Okay, the compression is good, perfect. And right now we are going to calculate the volumetric efficiency. And with the volumetric efficiency, we start the process to calculate the turbo recommended for that particular engine. All right, this is the next step. This is basically the principle of operation of the turbo. Don't forget, the turbo is divided in the hot side. The hot side is the input of the turbo, where the exhaust gases enter and spin the turbine. The turbine is connected to the same shaft with the other turbine, the turbine of the compressor side, and suction fresh air from the air filter, and the air filter is compressed and enter at high pressure into the combustion chamber. Remember, in this picture, normally in this point, before the air enter in the combustion chamber, you have what is the name of this element? Yeah, is the intercooler or aftercooler. Intercooler or aftercooler. In order to reduce the temperature of the air, in order to avoid vapor lock. Yeah. The intercooler is located in between the output of the turbocharger and the input of the intake manifold. In between the output of the turbocharger and the input of the intake manifold. Yeah, I explained in a lot of videos in previous episodes where is located the intercooler or aftercooler. Okay, if you check in this particular picture, we have in the shaft a couple of bearings. Yeah, and those bearings are lubricated exactly in the video that you have over there. In the middle, in between both wheels, enter the oil. That oil is coming from the engine, and that oil lubricate both bearings. The oil never pass through the turbines because the seals are located exactly one seal in each side. Those seals avoid that the oil penetrate the cold side or the hot side. What happens if the seal located in the cold side, the seal is broken? The oil penetrates that point. What happened? The fresh air enter in the combustion chamber mixed with oil, and now you have fresh air mixed with oil. And what is the consequence? You have blue smoke. Yes, my friends, there are two possibilities. There are like a 3 or 4. Two possibilities for blue smoke. What is the first one? Yes, the first one is problem on the valves, the head valves. Problem in between the valve and the guide of the valve. Problem on the seal of the valve, correct. Yeah, the oil penetrate over there, enter in the combustion chamber, and blue smoke. Of course, if the piston rings are broken, the oil, you don't have oil controller ring, and the oil pass into the combustion chamber. This is the worst scenario. And now, because the air, the fresh air coming from the turbo is coming mixed with oil because the seal is damaged. This is another possibility for blue smoke. Yeah, this is very common in diesel engines. Problems on the turbo produce blue smoke. Wonderful. This is another great possibility. Some people say, Mr. Lopez, what about the oil cooler, the motor, the engine oil cooler? If the engine oil cooler is broken, is possible blue smoke? No, my friends. What happens if the oil cooler is broken? The oil, the motor oil is mixed and you have milky oil. Yeah? What is the consequence when you have milky oil? Immediately the gauge of the temperature gauge goes up, and other gauge, the pressure gauge, goes down. Yeah, when the oil cooler is damaged. And now we are going to check what happened in the sample of oil. You found that what? All right. Right now we are going to talk about that. Okay, my friend, this is the situation. Yes, we have in the shaft of the turbo, two turbines. One turbine for the hot side, and other turbine here for the cold side. Right? Normally the color of this one is silver, like aluminum, and the color of this one normally is like a brown color. Right? Yes, we have bearings here, we have bearings, and we have additionally seals here and seals over there, in order to avoid that the oil coming from the engine penetrate and enter in both sides. Right? Yeah, the oil is coming from the engine at the pressure of the engine, the pressure that you have in the oil pressure gauge. Exactly. And that oil enter, like the picture over there, and return into the oil pan again, and the cycle continues. Remember, the motor oil lubricate two external elements. One external element is the bearings on the turbo. That's the first one. What is the other one? Correct. The other one is the governor of the fuel injection pump. You remember? The governor that moved the rail? Exactly. That mechanism is lubricated with motor oil. This is a typical question when you try to apply for companies, Caterpillar, Cummins, Volvo, Detroit Diesel. This is a very common question. All right? Those two external elements are lubricated with the motor oil. Yeah, the governor on the fuel injection pump and the turbocharger. The turbo and the supercharger also is lubricated with the oil coming from the engine. Both of them. Okay, my friends. Don't forget that the pressure, the atmospheric pressure is 14.7 psi. 14.7 is 1 atmosphere. Is the equivalent. The turbocharger increases the pressure at the point where air is entering in the cylinder. Yeah. Basically, the idea is increase the amount of oxygen. Remember that the air is not pure oxygen. The air is a lot of nitrogen and other components and oxygen. But oxygen is not the main component of the air. Alright, what happens if I try to introduce more air than the recommended maximum air accepted for that combustion chamber? You produce detonations, flame, misfiring. That's not good. You can destroy the face of the valve. You can erode the face, the head of the piston. If you try to introduce excessive amount of air. Yeah? How can I avoid that problem? Yes, with the shut-off valve or wastegate. This is the technical name, and we are going to try to understand today where is located the wastegate and what is the function of the wastegate. Where is located and what is the function of the wastegate. Yes, my friends. The turbocharger is simply a device that pumps air. It's a pump of air driven by the exhaust gases. That's it. This is the situation. The exhaust gases enter over there, move this turbine, spin the turbine, the excess of gases goes out, and in the other side, the fresh air enters from the air filter over there. The fresh air is full compressed and goes over there, and after that, an element located here is the intercooler, receive the air, and after that the air continue with the temperature appropriated and enter in the intake manifold of the engine. This is the situation. This is the turbo. It's not complicated. Remove the turbo is too simple. It's basically 4 volts. Install the turbo is too simple. The problem is calculate the turbo appropriated per each engine. Right now we are going to start with the turbocharger components. We are going to verify each element of the turbocharger. Alright, the turbocharger is composed by the compressor housing and the wheel of the compressor. This is the cool side. In the other side, in the hot side, we have the housing and the turbine. The materials of those elements are different like the materials of those elements. Right now we are going to check each one in particular and the color of each of those elements. In the center, in between both housings, we have the housing bearings. This is the element that receives the oil from the oil pan, lubricate the bearings and the shaft, and return the oil into the engine. The first element is the path of the oil. Now we are going to check how the oil is moving. The oil enters in the bottom, coming from the oil pan with the same pressure, the regular pressure of the engine, circulate internally, lubricate the bearings, and return on top into the oil pan. This is the procedure to circulate the oil. Is the motor oil. The bearings on the turbocharger are lubricated with the motor oil. This is the path. The oil enters over there. The oil pass for this cavity, enter here and pass for this cavity, and keep properly lubricated this bearing and this bearing. Those bearings, right now we are going to check, are special bearings, plain bearings, and those bearings are working at ultra high speed. This is the housing. Normally this is the input of the oil. Normally we have a gasket located here in order to avoid that the oil at high pressure, around 60 psi, produce a leak in between the block of the engine and the housing of the bearings. The oil penetrate over there, circulate and return on top into the oil pan. Okay, this is the gasket. This is the gasket where the exhaust manifold enter. That gasket is important. The dimension of this gasket is important where we select the turbocharger appropriated for that engine. This is the next step. Okay, and this is the housing on the hot side. The housing on the hot side is fabricated in a cast iron. Normally, the color of this housing is brown because it's regular cast iron, and is covered with an special fiberglass insulation material, because the temperature of this housing is high temperature, and this is the element that elevates the temperature of the engine room. Normally, in this housing is located a cavity outside. Internally, have a cavity where the coolant enter. Normally, we have a coolant coming from the engine. The coolant that circulates in the engine and the block enter over there, circulate here, and return in the bottom with other feeding into the expansion tank. You remember the expansion tank with the radiator cap? Okay, the coolant enter over there in order to keep the external side of this element properly lubricated. Exactly like the picture that we have on the screen. Exactly in this area outside, the coolant is circulating. Alright, the material is cast iron, and normally this element is because the differential temperatures is cracked, and it's not possible repair that housing. You need to replace the housing. The cast iron is an alloy, difficult to weld. For that reason, I don't recommend try to weld the housing of the hot side when it's broken. Replace that. Okay, right now we are going to check the turbines. We have one turbine in the hot side, and we have another turbine in the cold side. Yeah, the material of this is aluminum, cast aluminum. Is an aluminum alloy, and this one in the hot side normally is a special steel with vanadium, with high content of vanadium. This is a special steel for high temperature, vanadium and titanium. Don't forget those elements, because when we send the oil to the laboratory, if we found that this is a high content of vanadium and titanium, probably is because the rotor in the hot side of the turbo is eroded. A couple of blades are broken, and this is the material, vanadium and titanium. All right. And in the cold side, the material is cast aluminum. It's a special alloy of aluminum. Cast aluminum is light. It's not heavy. The color is silver, and it's the same material. Like the turbine. The turbine in the cold side is fabricated in aluminum normally. And is a soft metal, and this is the metal that if you remove the air filter and you introduce a penny or any piece of metal, you destroy those blades, and those pieces of metal enter in the combustion chamber when the intake valves open and destroy the combustion chamber, like this example. For that reason, you need to be careful when somebody is working in the engine room, and I recommend remove the air filters, cover that area with the blue tape in order to avoid that somebody introduce pieces of metal in the turbos and destroy the engines immediately. That situation will be catastrophic. Yes, in the center where the oil enter is the bearing housing. The bearing housing allow that the oil enter over there, penetrate and lubricate the bearings. Look at this. The bearings are running more than 150,000 RPMs. This is a high speed. For that reason, the bearings located on the shaft, those bearings are special bearings. This is a bronze alloy. This is a bronze with a high content of phosphorus and a little amount of sulfur. This is a special plain bearings for ultra high speed. Is in between 150 and 170,000 RPMs. This is a lot of RPMs. When those bearings are damaged, normally you need verify the play on the shaft. When you check the turbo, I recommend that practice. Move exactly like I am doing in this moment. Move the shaft laterally in order to verify if you have play. If you feel a little play, it's because the bearings are out. How can you verify that situation? With the oil sample. If in the oil sample you have high content of phosphorus, it's because those bearings are gone, and you need send the turbo to the machine shop in order to replace those bearings, because they need a special equipment, hydraulic press, in order to replace those bearings. I recommend don't try to fix the turbo by yourself if you don't have experience. If you have experience and the tools, of course, you are very welcome to do that process. Those are the bearings, and the bearings are located over there, and after that are located the seals. And those are the seals that avoid that the oil penetrate in both sides. The oil penetrate the cold side and the hot side. You remember we talked previously about what happened if the air coming from the filter enter with oil. Of course, you have a blue smoke. And in the exhaust side, what happened if you have a leak of oil in the hot side? The smoke going out through the exhaust pipe is going with oil. And you found it around the oil pipe, a lot of oil accumulated over there. This is an indication that the seals on the turbo are damaged. Be careful with those seals. And other indication that those seals are damaged is because you have a suddenly low oil pressure in the oil pressure gauge, and the bearings are okay, the engine is in good condition. Probably the problem is on the turbo. This is another possibility for low oil pressure. We are going to include that possibility in our big table of problems, codes, cause and solutions. All right, my friends. Yeah, this is typically the movement of the oil. The oil penetrate over there, enter here, oil penetrate over there, enter here, and lubricate the bearings and keep the bearings in excellent conditions. All right, and right now we are going to talk about the west gate. The west gate is a special window. Now we are going to talk about the west gate. The west gate is a special window located in the hot side of the turbo. That window located in the hot side of the turbo, the function of that window is allow that the excess of gases, when the engine is in idle, the excess of gases goes directly through the exhaust pipe and rotate the impeller of the turbo at low speed. When the turbo is spinning at low speed, introduce a little amount of extra pressure into the intake manifold, low boost pressure. When the window is open, the majority of the gases goes directly outside and the turbo is spinning at low speed. And probably the boost pressure introduced is practically nothing. When the window is closed, the majority of the gases spin the turbine, and in the other side suction the maximum amount of air, compress the air, and introduce that air full compressed into the intake manifold. This is exactly the situation that we have in this example. Yeah, the west gate is activated for a solenoid. Normally the solenoid could be electrical or a vacuum solenoid. It is vacuum solenoid, like the solenoid that we have on the screen right now. The vacuum pressure is coming from the intake manifold. Yeah, that solenoid, that vacuum solenoid, is working together with the map sensor. According with the suction pressure in the intake manifold, the negative pressure in the intake manifold, that information, the computer send the information to the solenoid, and the solenoid open the window completely or partially. The window open and close depending of the negative pressure sensed by the map sensors and the signal on the computer. The computer send the information to the solenoid, and the solenoid extend or retract and open or close the window, and the gases go directly outside or directly into the wheel, into the turbine. This is the function of the wastegate. Is basically protect the engine in order to avoid excessive amount of boost pressure during the idle position. It's simple. There are different type of wastegate. In this particular case, this is mechanical. This is used with a vacuum information. Yeah, one information is coming from the map sensor, and the other information here. One information is coming from the map sensor, and the other one is coming from the intake manifold. All right, both of them compensate, and this element extend or retract and open or close that window. This is the mechanical. There are other ones electronic. Yeah, this is the signal. The signal enter here, and internally it's too simple. It's a diaphragm. Yeah, membrane, and a spring. The spring returns the membrane, and according with the pressure enter here and deformate the diaphragm. It's too simple, and this element is connected with the link, and the link is connected with the flap. Open or close the flap. It's too simple. All right, and exactly, this is the situation. Exactly. The gases enter here. If this window is open like this, the majority of the gases goes out directly outside. If this window is closed, the majority of the gases enter here and spin the turbine, and the turbine in the other side have the other impeller, and the other impeller is located with the other housing. And here is located the air filter. The other housing suction the air at high pressure and send the air with high pressure into the intake manifold. Yeah, this is the function of the wastegate. In this particular case, the wastegate is electronic, and the wastegate is controlled by the computer, like I explained before. The new engines, they have the wastegate electronic and pneumatic, because according with the signal from the map sensor sends the signal to the computer sends and immediately sends the signal to the actuator, and the actuator extends the amount recommended by the computer. Yes, the map sensor, the ECM, and the wastegate work together in order to compensate the idle RPMs. For that reason, my friends, in the majority of the diesel engines, when you have problems with the idle RPMs, with the idle calibrations, where you modify those RPMs in order to synchronize both engines? Yes, in the actuator of the turbo. Let me explain where is located that actuator. Look here. This is the wastegate actuator, and this is the bolt, and this is the nut. Yes, you lose the nut and you modify the length of the actuator, and right now the RPMs in idle are lower or higher depending how I adjust this bolt with this nut. It's too simple. It's exactly the same like when you adjust the control cable for throttle or the control cable for gear. You lose the nut, you adjust the bolt, and you tighten the knot. Exactly the same This one is to calibrate RPMs. This is to calibrate RPMs. Don't forget. You remember in what cases you need to calibrate the RPMs, the idle RPMs and the wide open throttle RPMs? You remember in intro what happened when you modify the pitch of the propeller? You remember? Each additional inch that you added to the pitch is 200 RPMs less in wide open throttle. Each additional inch that you reduce in the pitch is 200 RPMs more. How can I compensate that? Over there, in the ball of the wastegate at the turbo. In that point, you adjust the idle and the wide open throttle RPMs, especially the idle. This is for idle. Alright? You like it? This is very, very, very important. In this ball, you calibrate the idle. Yes, I have a question. What should be the position of the window, open or closed, when the engine is, the window of the wastegate, of course, when the engine is in idle? The window of the wastegate will be fully open or fully closed in idle? Yes, fully open. In wide open throttle, completely closed. Correct. 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 This is the secret. In idle, the window should be open. In wide open throttle, the window should be closed. All right. Where you calibrate it? Here, in this bolt and nut. This is the procedure to calibrate the bolt and the nut. And this is another picture of the hot side of the turbo with the window of the wastegate. All right, my friends. Don't forget, this is the element used to calibrate the RPMs in idle. Yeah, the inspection of the wastegate, I recommend periodically lubricate the shaft of that window, lubricate that area, because that area is exposed to exhaust gases with salt water. If the engine is not used periodically, suddenly that window is damaged. I recommend keep lubricated that window periodically with a WD-40, any type of oil, and remove it from the shaft of the actuator and lubricate the window. That's very, very, very important. Okay, my friends, and right now I am going to talk about the superchargers. There are two types of superchargers: positive displacement and dynamic displacement. The positive displacement superchargers are the most common in diesel applications. In positive displacement, those superchargers are driven by electric 12 volts or 24 volts. Is common in diesel engines, small diesel engines and medium applications. Also, superchargers where the connection is gear to gear in big diesel engines, and superchargers driven by belt. It's very common in diesel and gasoline, diesel, small and medium engines, and gasoline engines. Is common the connection by belt. Remember, my friends, in two-stroke diesel engines, that the two-stroke diesel engines, the air enters in the bottom, and the air is coming from a blower. That blower is the supercharger. On top of the supercharger, you have the air filter. The air enters on top of the supercharger. In the bottom of the supercharger, enter into the holes of the cylinders. Because remember, in two-stroke diesel engines, the cylinders, the liners, have those holes in the bottom. For those holes, the air enters in the bottom at high pressure because the blower introduce the air at high pressure. And in the moment that the fresh air enter at high pressure, on top, the exhaust valves are open, producing the scavenging. It's very common. Remember, we have scavenging in two-stroke diesel engines in this way, because in the moment that the pure air enter in the bottom, full compressed, coming from the supercharged, the exhaust valve is open on top and push the smoke out. This is the scavenging in two-stroke diesel engines. The scavenging in four-stroke diesel engines is in the moment of the overlap. You remember? At the end of the compression stroke, just at the beginning of the intake, both valves are open, and the fresh air pass and move the gases outside. Overlap in four-stroke diesel engines to produce scavenging, and fresh air entering in the intake port at high pressure, pushing the smoke into the exhaust port because the exhaust valves are open. This is for two-stroke diesel engines. Very, very important that you keep clear that concept. In diesel engines two-stroke, it's very common superchargers. It's most common than the turbocharger. In four-stroke diesel engines, there are both of them. Engines supercharged and engines turbocharged. In two strokes is most common supercharged engines. Yes, because the air in two-stroke engines enter in the bottom, in the side of the block, not on top. Alright, for that reason, the supercharger is very common in those type of engines. Pay attention to this sentence. In the supercharged engine, the closing of the intake valves is slowed down so that the intake valves or pores are open for a long period of time after the exhaust valves close. Yes, the engines with the supercharger are designed to be used with supercharger. The camshaft is special because the lobes, the angle, and the shape of the lobe, you remember that picture? Exactly, is rounded in order to keep the valves, the intake valves, open for a long period of time in order to introduce more air. The increased time that the intake valves are open allows more air to be forced into the cylinder before the start of the compression stroke. Yeah, it's because the shape of the lobes. Yes, my friends, the engines, the supercharged engines, they have a special camshaft for supercharged engines. It's exactly the same like for turbo. For that reason, it's important verify if that engine you want to convert the engine, your engine is naturally aspirated, and you want to convert the engine into turbocharged. Yes, it's important verify if the camshaft should be replaced, or if you want to convert it into supercharged, ask if the camshaft should be replaced for other special camshaft with the special angles on the lobes. The amount of additional air that is forced into the cylinder and the resultant increase in the horsepower depend on the pressure in the air box or intake manifold. That's critical. Okay, my friends, we are going to check the video that we have prepared for the explanation about the. This is those are the roots. Those are the roots. The roots are coming in two versions. Helicoid like this, or straight like this in this video. Both of them are commonly used. One important thing right now I am going to explain is about the bearings. Yeah, exactly. This is the output, high pressure. This is the movement of the roots. This is the input where the air enters at high pressure. That's the input. Correct? That's the input. The air enters at high pressure over there. The air filter is located over there. and this is the output. This is the bracket. That bracket on top is the bracket that is bolted on the intake manifold, or is bolted into the intercooler, and after the intercooler the air enter in the intake manifold. Yeah, this is the movement of the roots internally in the high pressure side, in the output of the supercharger.